All right, so I got here. So you plug into the function and you get a point. You got to plug into the derivative of this function above us. So this would wind up being a negative, let's see, 2/5 times sine pi t over 4, and then the derivative of the inside would be pi over 4, like that. So if we plugged in, say we plugged in 2, sine of pi over 2 is 1, so this is negative 2/5 times pi over 4, right? So we would get negative pi over 10. Okay. Now to use the tangent line, my tangent line would be, use the point and your slope. So the tangent line would be y minus 32 over 5 equals negative pi over 10 x minus 2. So we could write it negative pi over 10 x minus 2 plus the 32 over 5. And then to approximate w of 2.5, you would just plug that in. So here you would get negative pi over 10, 2.5 minus 2 plus 32 over 5. It would look like that. So that would equal, so this is 1/2, so negative pi over 20 plus 32 over 5, okay? We just want to show that that is greater than 6, right? Yeah, we want to show that that's greater than 6. So in order to do that, we're going to say that because the graph is concave up, from 2 to 2.5, right? The tangent line approximation of the w of 2.45 is an underestimate Okay, so since it's an underestimate of the actual value, right, then we know that W 2.5 has to be greater than what we got, which is greater than or equal to 6. Okay, let's go to part C. Oh, part C is cool, the limit. Okay, so part C, they give us, what's the limit? T goes to 2, W of t minus t squared minus 12/5 all over t minus 2. Okay, so remember, your first step always is to plug in what you're approaching. So 0, W of 2 we did, right? So W of 2, we got 32 fifths minus 4 minus 12 fifths, right? So this is going to give us 0 over 0. So remember, if that happens, right, that means a limit does exist. Do something. Okay, so what I'm going to do is L'Hopital's rule, right? So in L'Hopital's, okay, you're going to take the derivative of both the numerator and denominator. Okay, and now I can plug in 2. We already did W prime of 2. Came out to that negative pi over 10 minus 4. So there's our limit. All right, let's go to question number 2. All right, so question number 2, they give you a couple equations of particle P and particle Q. Okay, we want an A to show that the velocity of P is going to be this negative 5t e to the 2 minus t minus 5 e to the 2 minus t all over e to the 2 minus t plus 3t squared. All right, so what you want to do here is take your derivative. So we're using product rule. So then I'm going to just show v of particle P of t, right? So my derivative of the numerator would be a negative e to the 2 minus t minus 2 times the denominator, and then minus negative e to the 2 minus t plus 3 times the numerator, and then all over the denominator squared. All right, so then on here, we have to do some distributive property, right? So when you do this distributive property here, you're adding exponents, okay? So you're gonna get a negative e, and now I want to add the exponent. So negative e, so 2 plus 2 is 4, right? So 4 minus 2t. And then now we could do our distributive property here. So minus 3t e to the 2 minus t minus 2 e to the 2 minus t, right? Here I'm going to get a negative, let's just do it this way. So you have a negative, same thing, e to the 4 minus 2t minus, oh, no, so this is plus 2t e 2 minus t. And then minus 6t. Over here we also have a minus 6t, right? So you have it like that, sorry. And then it's over e to the 2 minus t plus 3t squared. So you can see these are going to cancel. These are going to cancel. Here we have negative 3t minus 2t is negative 5t e to the 2 minus t. And then, so I got rid of those two, and then negative 2e to the negative 2t minus 3 is going to give me a negative 5e to the 2 minus t all over e to the 2 minus t plus 3t squared. So you do have that work out, okay? That was just a bunch of work that you had to do. Now, on part B, they're asking at time equal 2, particle Q is at rest. Okay, and so they're asking at time equal 2 is particle P moving towards or away from Q. Okay, so in part B, we want to find the position to see where they're at, particle P and particle Q, and then knowing that Q is at rest, we want to see, you know, which direction would P be going, and then we could tell it's moving towards or away. So like Q, like position of P at 2, right? So I'm going to plug that into X of P, right? So you get e to the 2 minus 2 minus 2 times 2 over e to the 2 minus 2 plus 3 times 2. So this gives me negative 4/6 or negative 2/3. Oh, no. 1 plus negative 3/7. What am I doing? Okay. Remember, this is 1. And then the particle Q at 2, let's plug that in. So 2q minus 3 times 2 squared plus 5 equals 1, right? 8, yeah, 1. Okay. Now, like, think of them on the number line, right? So you have this is particle Q, and negative 3/7 is particle P. So you want to see like now you want to see like what's the velocity of particle P, and then you could tell if it's moving away from or towards, you know. So I'm going to plug that into the velocity of P at 2, and you can see that we did that in the first problem, right? We got that velocity, or we just showed that that velocity existed. So it would be negative 5 times 2 e to the 2 minus 2 minus 5 times e to the 2 minus 2 over e to the 2 minus 2 plus 3 times 2 squared, right? So here we're going to get, this is 1, right? So this is negative 10 minus 5, right? So negative 15 over, this is 1 plus 6, so 7 squared, so negative 15 over 49, right? So since this is negative, right, then we know particle is moving left, okay, which means if it's moving left, think about that, it's going that way, moving left, then we know particle P is moving away from Q. Okay. Next one. C. Let's look at C. Oh, C is nice. C just wants to know what is the, like they say, find the value of AQ, or acceleration of particle Q at 2. Okay, so what you want to do take your derivative, which would give us a velocity of Q. And now we could take our acceleration of Q, right? And then we could plug in 2. So that would give us 6. That was a nice and easy one that we got. All right, so for part D, it says describe the position of particle P and the position of particle Q as T approaches infinity. Okay, so when you see that, really what that's meaning is, what's the limit as T goes to infinity for the position of P, and the limit as T approaches infinity for the position of Q. All right, so for the first one, right, so if we're doing P is probably the tougher one because you're doing the limit as T goes to infinity of this. Okay, so for both of these, you could see that these are both going to infinity. One goes to negative infinity, one goes to positive infinity. And when that happens, it's an indeterminate form. It's almost like 0 over 0. So we want to use L'Hopital's. So if you take the derivative of top and bottom, right, or numerator and denominator, here I'm going to get that negative e to the 2 minus t minus 2, and negative e to the 2 minus t plus 3. Okay, so when you do that, you could see here that this e to the 2 minus t is going to go to 0, giving me negative 2, and 3 in the denominator. So that's our limit for the particle P. Now the limit for particle Q the limit for particle Q would just be infinity, because your leading coefficient is positive and it's a cubic function, so you know that your end behavior, it's just going to keep going up. All right, and that was it.